All right, last page of 9.1, right? So page 6, right? So we take this equation, solve it for n, and after doing some algebraic magic, we end up with this formula right here, okay? So the sample size that we need in order to obtain 1 minus alpha times 100% confidence interval for P with some margin of error E is given by this formula. Okay. Now, chances are, if you're trying to figure out the sample size you need in order to estimate P, you probably don't have a prior estimate for P, right? You probably don't have a value for P hat. If that's the case, then you can just replace the P hat times 1 minus P hat part. You can replace that with 0.25. That's the largest that P hat times 1 minus P hat can ever get, okay? So we use this top formula. If we have a prior estimate. We use this bottom formula if we don't have a prior estimate. And I'll give you an example of both of those, okay? But one thing I will say is that in both cases, we're going to do a weird kind of rounding. Okay, so in both cases, we're going to round up. We're going to round up to the next integer. So we're not going to round off, we're going to round up. So that means that even if we get an answer here of 15.1, we're still going to round up to 16. Because if we get an answer of 15.1, then that means that we need at least 15.1 individuals in our sample, okay? But you can't have 0.1 individuals. If you need at least 15.1 individuals and you only use 15 individuals, that's not enough, right? Because you needed at least 15.1. So that means in reality, you needed 16 individuals in your sample, okay? So regardless of the decimal point that we get, we're always going to round up to the next integer. Let me give you a couple examples. So example 6 says the use of the internet is constantly growing. How many randomly selected adults must be surveyed to estimate the percentage of adults in the United States who now use the internet? Well, doesn't everyone use... In the United States, I think just about everyone's using the internet now. But anyway, we'll go along with this. This is an old question, obviously. It says, assume that we want to be 99% confident that the sample percentage is within 2 percentage points of the true population percentage. Okay, so part A says, what sample size is needed if nothing is currently known about the percentage of adults using the internet? Okay, if nothing is currently known, then we're using the bottom formula here, right? Nothing is currently known. We don't have a prior estimate, so we're going to use that formula right there. In order to use this formula, we need to know what z sub alpha over 2 is, and we need to know what E is. So let's focus on z sub alpha over 2. In order to get z sub alpha over 2, we need to know what alpha is. Alpha is related to our level of confidence, right? We want to be 99% confident, right? So if our confidence level is 99%, then that means that alpha has to be 0.01, right? 100% minus 99% is 1%. If alpha is 0.01, then that means z sub alpha over 2 would be z sub 0.01 divided by 2. That would be z sub 0.005. And now remember, we go to StatCrunch to get that value. We use the normal calculator in StatCrunch to get that value. So let's go to StatCrunch and figure out what we get for z sub 0.005. Okay, so we're going to go to Stat, Calculators, Normal. Leave the mean at 0, leave the standard deviation at 1. We want an area to the right. We want that area to be 0.005. And so that comes out to about 2.58. Okay, so that's good. So we have z sub alpha over 2. The other piece that we need is e. So let's look back through the problem, right? It says, how many adults must be surveyed, blah, blah, blah. Assume we want to be 99% confident that the sample percentage is within 2 percentage points. Within 2 percentage points. There, right? They're giving us the margin of error. They're saying we want our estimate to be within 2 percentage points, right? So E must equal 2%. When you use it in this formula here, you need it to be as a decimal though. So we'll say as a decimal, that's 0.02, right? So E, 0.02. So putting it all together now, we can say, all right, so N is approximately 0.25 times Z sub alpha over 2 divided by E squared. In our case, that would be 0.25 times 2.58 over 0.02 squared. Okay, let's see what we get. Type it into your calculator exactly the way it looks, right? Use parentheses around the fractions before you square it. Right, so I'm going to say 0.25 times, open parentheses, 2.58 divided by 0.02, close parentheses, squared. And then I hit enter, and I'm coming up with 4,160.25. We're going to round up to the nearest integer, right? So if you need 4,160.25 individuals in your sample, then really you need 4,161 individuals in your sample, right? So we would say N is 4,161. Okay, that's it for part A. Now part B, on the other hand, says what sample size is needed if we have a prior estimate of 73%? Okay, so this time we have a prior estimate of 73%. Everything else is the same, right? So our confidence level is still 99%, and that means our critical value, Z sub alpha over 2, should still be approximately 2.58, right? We did all that work in part A already. Our margin of error is still 0.02. But what's different is that because we have a prior estimate, we get to use this top formula now. Right? So we're going to use this top formula for part B. We're going to say N is approximately P hat times 1 minus P hat times Z sub alpha over 2 divided by E squared. P hat is 73%, right? So this is going to be 0.73 times 1 minus 0.73, that's 0.27, 0.27, times Z sub alpha over 2, 2.58, divided by E, 0.02 squared. Okay. Again, punch that into your calculator exactly the way it looks. I'm going to say 0.73 times 0.27 times open parentheses 2.58 divided by 0.02 close parentheses square and you should end up with 3,279.94. So we would say N equals 3,280. Okay. And that's it for that. Notice that, again, these are the same. Your confidence level is the same. Your margin of error is the same. What's different is that in part B, you had a little bit more information. You had a prior estimate. And consequently, your sample size didn't need to be quite as big. Okay? So you could get away with a slightly smaller sample size, which is probably good for your budget, right? Anyway, so that's that. Here's your homework assignment. You can use StatCrunch on all of the problems. So I think earlier I said I might have you do some of the confidence intervals by hand. I guess not, right? So I'm not asking you to do any of them by hand. You can just use StatCrunch for all of them.